Okay, we got a really cool challenge here in the 7 Caillou series. Knight versus King. It's cool at least if you're a chess nerd like me. So we have Knight versus King. If you're not familiar with chess, you can look here. I'm not going to explain the game of chess. I'm going to assume you know that, so go ahead and do any research you want. They show a depiction of the board, and in chess you call the rows ranks, and then vertically, which are depicted with letters here, are known as files. So you've got ranks and files. And if you're familiar with chess notation, you've probably heard someone make comments like knight to, b3 or whatever. And that's sort of the idea here. You match the b with, the rank number, and you can uniquely identify each square, and you can describe a chess game that way. And if you take notes to examine your games later, that's helpful to write down the moves. So anyway, you put a knight and king on the board. Complete the method that tells us which one can capture the other. You are provided with 2 object array, which is a bad choice. We'll get into that, but we'll have to accept that. It's their challenge. Each contains an integer, the rank, first item, and a string, the second item, to show the position of the pieces on the chessboard. So if you look at your method over here, you'll notice these object arrays. They're size 2, right? And the first value is going to be an integer representing the rank, and the second one's going to be a string representing the column. Not a way you wouldn't want to make object arrays like this. We'll get into that. Anyway, returns knight. If the knight is putting the king in check, that means the knight is attacking the king. King, if the king is attacking the knight. And none, if neither piece is attacking the other. So check out the example. Unfortunately, they do this backwards. We often refer to squares as B7, not 7B. But we'll have to bear with that for this challenge. And it returns king, because if you want to look up these coordinates on the chessboard, you'll notice that the king is just diagonally 1 square away from the knight and could attack the knight. And again, if you don't know chess, you can look up how the knights move. They move in a sort of L shape where they can move up or over 2 squares, and then in the opposite direction they can go one square. It's hard to explain, but if you look at a picture, it's easy. But hopefully you know chess. So go ahead and put some thought into this one and give it an honest attempt. Now, I'm going to warn you, what I'm about to do is complete overkill for this challenge. I'm sure I'll have the longest solution that we'll probably see, but this series is meant to teach coding. It's not for me to race through challenges and just try to rack up honor points. So we're going to be putting you in uncharted territory probably. Just be a sponge, try to soak up what you can, accept what you don't understand, and maybe come back a day or two and watch the video again, and you'll notice that you sort of digest more of it each time. But this is part of the process, is challenging you and getting you exposure to new things. So I kind of hinted that I don't like this object array describing the positions. So I'm going to make a class that describes a position, and it'll be a very simple class that will have integers representing the rank and the file. And I'm going to convert the string into an integer as well, instead of using the letter representation, because that, when we talk about calculating which squares a piece is attacking, it'll be easier for me to do that if I can sort of offset with numbers. You can imagine if I'm on a file, I might want the next file over, and it's easier for me to just say +1. If I'm on the second file instead of the B file, then the next square I can think of as 3. I can just add 1 to the 2 to get there. And this will be made more clear as we go. So I think the best thing to sort of highlight my intentions here for the overall plan will be to sort of write the algorithm out, even though I'll use syntax and statements that won't compile right away, just so you can see the flow. and then we'll go in behind and sort of backfill and make everything jive. So to that end, wouldn't it be nice if we had some classes that represented board positions, chess pieces, things like that? Then for any given piece, we could just kind of say, give us your attack squares, and we could see if another piece is location was contained in that collection of attack squares. So let's do something like that. To start, I will say something like knight. I'm going to make this class called knight. And to do that, your typical constructor, right? And then my idea is that I'm going to have this base chess piece class. So I'm going to have, you can imagine I'll do the same thing with the king too, right? I'll have king equals new king. And the idea is that knight and king will both derive from a base class called something like chess piece. And with that, I can generally call get attack squares. And since they both derive from that chess piece class, they'll both have that method, and I can handle them in a uniform way. Now, in my line of thinking, it doesn't make sense to just initialize these empty, right? The relevant information to me is that this chess piece needs to be initialized with a starting location where it's located on the board. And for this problem, they provide that to us, right? But I said I wanted to use integers, right? I don't want this letter nonsense. I don't want object nonsense that I gotta convert when I have this board position class that contains those integers. I can just feed that in, right? I can say new board position. That'll be initialized with those values. So you can imagine the king's gonna work in a similar manner, right? And we gotta provide that information in. And they give it to us, sort of, but we've got to massage it a bit. I'm gonna shorten these names up just so I can make things, try to keep things on screen. That's still, okay, so the first value is the rank, and the second one's the file. So I can say knight position 0. And then, remember, this won't work initially. We're going to fix it. The idea is that we do something like this. But this is going to come out as a string, so we're going to have to handle a conversion into an integer for that. Let's start to, so we're not too abstract here, let's start to make this board position class. And that might make things a little easier to think about. So I'm going to have something like, call it board position. We define the scope of our class. Remember, this is just contained. We've got this overall knight king class. And so I can just put my own classes in here. In real life, you would make these into separate files, but I don't really have that here in Code Wars, coding right from the web. So I'm just going to put them as sort of nested classes in Knight King. So anyway, simple concept here, right? We're going to have, I'll set these as properties. We're going to have a rank, and we've seen properties in other videos, but feel free to review those if they're fuzzy. And file, really simple, right? We can describe a square on the chessboard this way. I make them get, so anybody can get these values. I set them to private, so I put the setter to private, so we can only modify that information within this class, right? We wouldn't want people working it to be able to change those positions. That could sort of corrupt the data. So use some encapsulation there. And then it doesn't make sense to sort of have an empty constructor, right? We need these values to sort of conduct business. So I'll say int rank, int file, right? That's our constructor. It's going to take those values, and then we can simply assign them to our properties. We can say rank equals rank and file equals file. So hopefully this makes it a little more clear. The board position is very simple, right? It's just representing, you know, one of those chess squares that gives us that unique spot on the board where a piece will be located. And you can imagine this is very relevant to a chess piece. It can change over time as the pieces move. So in a real scenario, you might want to be able to modify these to play with moves. We're not going to be moving, so I won't worry about that here. But you can see, right, that with this constructor, as I'm trying to do up here, this just doesn't jive, right? You got an integer here and a string there. So let's do something where we can convert the string value representing the rank to an integer. And for that, I'll just make a helper method. I can do something like private static int, and we'll call it get rank number. And it should take a string. That's what we're converting from. And then I think we've used the switch statement before, but it's very much like a series of if-else statements. If one condition, else if, and finally an else. It's sort of another way of doing that with a couple other little features. So the way this looks is that you list your cases. Case A, right? And for A, I'm going to return 1. If you remember the board and the instructions, they're using a 1 to 8 numbering system for the ranks. I'm going to use the same 1 to 8 for the letters. So you can go ahead and copy this. D, E, F, G, H. And I'll fix those. And then you got this cool little default option with switch statements that says if none of those previous cases matched, then you get here. And I'll say throw new argument exception. We can say invalid rank provided. The challenge here won't do this. I think it was called rank. So let's make sure these are all accurate. B, C, D, E, F, G. And then make sure you get the right file number. 6, 7, 8. Okay, so I think we got that. So now we have this nice little helper that will make that conversion for us. So I should be able to do something like, and if you want to break these out into separate statements so they're more clear, feel free to do that. Just create some variables before this. Okay. Knight position 1 was a string, and then we're going to do the same kind of thing, right, for the king. Except, of course, we got to call it king position. We don't want to put the king also in the knight spot. That, of course, would be beyond just wrong. It would be illegal in chess to put 2 pieces on the same square. So we're going to have something like this, right? And then you can imagine once we have our 2 pieces, wouldn't it be nice if we could do something like if king, let's say get attack squares. Just imagine that this chess pieces had this behavior, get attack squares, that would just return you a list of all the squares that they're attacking, because chess pieces can attack multiple squares usually. And then we could say, so imagine this would give you that list, and imagine if you could just say contains knight dot location. Imagine if chess pieces had a location property that said what square they're on. And then you could see if, hey, is the square that the knight on, is it contained in this list of attack squares? And if it is, then I can say, per the rules, right, return king. And before I do that, one other little helper idea. I'm going to make an enumeration. Not sure if we've done these before at this level, but it just kind of, well, for lack of a better word, enumerates a set of values instead of just having any possible string used. I'll call mine attacker because that's what that's what our method wants to know, who's attacking. You can name your enum something better if you think. So you define the scope for it, and then you can just list values, potential values, like none was one of them, remember? And then we could say knight and king. And I don't think you don't need a comma at the end. I don't think you need the next value. We'll see. I can. So yeah, the idea is then I can say when the king's the attacker, I can say return attacker king. That's one of the values, right? And then I have to hit toString because unfortunately this method returns a string representing the answer. If I were making this method, it would not return a string. It would return maybe this enum, maybe it would return the chess piece that's attacking, something like that. But I'm trying to stay within the bounds of their method definition. I have to use that here, right? So I'm trying to, do good design where I can while fitting it into their structure here. And then similarly, right, if you hit this one, you're done, but provided that didn't hit, you would naturally check, well, is the knight attacking the king? They only gave us two possibilities here. We're not, to keep it simple, we're not scanning a whole chessboard and considering every piece like you would. And then I would say return the knight if it's attack squares. If one of them is the square that the king is on, return the knight. And then finally, if neither one of those hit, the only other option is to return none, right? So return attacker none toString. The toString just gives you the text of your enumeration names there. Okay, so I like that a little bit better than just dealing with strings that can be typed wrong. So this is the idea, right? This is the general strategy. Obviously, we have to fill in the missing pieces here to make this work, but hopefully this is clear. I'm instantiating a couple chess pieces, the only two that they care about in this challenge. I'm saying they're going to have some method to get attack squares, gives you this list of board positions, and you can see if any piece, its location is to be found in this list. So that's pretty handy. So next thing, let's go ahead and build the chess piece class first. And I'm going to use a class called chess piece, and I'm going to make it an abstract class because it won't be useful on its own. We have that behavior get attack squares, but short of knowing what the piece actually is, I can't do anything. I can't return attack squares because it's completely dependent upon which actual type of piece it is. But by making an abstract class, we can sort of put those things in common that all chess pieces have into this abstract base class, and then we can sort of leverage that and treat chess pieces in a uniform way. And that makes our logic, even if it sounds convoluted right now, it actually can make things simpler to work with. So let's make that. I'll say make another nested class, private class. I said I was going to call it an abstract class. And the idea with abstract classes is that you can't actually instantiate them, but you can derive from them, which we will do. So I'll say private abstract class chess piece. Okay, that's our scope for this new class. And so we already kind of talked about every chess piece is associated with a square, right, while it's in play on the board. So a chess piece should have a board location, right, that says where it is placed at any time during the game. And I'll use the same kind of idea here for this challenge, just to get, anyone can get it, only this class can set it. It may not work that way in an actual implementation, but I think you know where I'm going. And then we're also going to say that we have this behavior that all chess pieces have. I'm going to make an abstract method because I'm not going to implement it here. There's nothing to implement at this level, right? I don't know if I'm talking about a king or a knight. I can't even begin to say how this piece would move, but I can put the infrastructure in place, and I put board location, but we were calling it board position. So let me get that right. Sorry about that. So it's going to have this method that returns a list of board positions. I think we said we called it get attack squares, right? And I can just sort of declare the method like this. It's abstract. There's no implementation. I don't have to make curly braces and write a bunch of logic because I wouldn't know what to write anyway. You got to tell me what kind of piece it is, or I can't tell you how it moves, right? And then finally, I'm going to make a constructor for this class where you just use public in the class name to make a constructor. And again, a chess piece, you just got to know. I'm not going to leave a default constructor. And for this, we'll say it's going to take a board position that represents where the piece is located at. I can say location equals whatever's passed in. So when we make a chess piece, we specify right from the beginning where it should be placed. And I think that's a good strategy. So good, we have this sort of the foundation of our chess pieces. Now we can go ahead and make the derived classes from it. So you can think of this abstract class as sort of the base of a hierarchy of classes. And for that, let's start with the knight. I'll say class knight. And I think you've seen this, but use the colon to list any base classes that this class should derive from. And we said we were going to make it derive from chess piece. We got our scope here, good. And so now, basically to make a knight, I'll start with the constructor here, right? You just use the class name. And again, you need that board position, right? And I'll just call it loc, short for location again. And then what I'm going to do here is that I don't have to do anything special for the knight class. I just want to invoke chess pieces constructor, right? I don't need to do anything extra with the knowledge that this is knight. It just needs to be placed at a square like any other chess piece. So to do that with the constructor here, I can use the colon, and then I can say base loc, or location, right? And then I don't have to do anything. If I wanted to add some custom behavior, that if there was something extra that knights had to do when you created them, you could write that between these curly braces. You know what I mean? You can put them on a new line and write a bunch of statements if you want. I don't have to do that, so there's nothing extra to do. And what this base will do is go to the base class and give it that parameter. And we saw right here, this is the base class, passes location in. It will set the location property to whatever that value was. And knight can access this. Knight's derived. It can access location. So it's getting its location field set. Good. That's what we wanted. And then we have to sort of now define the behavior for get attack squares, right? And we can do that now because we know we're dealing with a knight and we know how knights move. So let's do that. I'll say public override, because I'm overriding this method from the base class. Override doesn't make sense if you don't have a derived class. So we see the return type. We've got a match. I'll just copy this so I don't hopefully make any typing errors. And this says we're overriding it, and now we can actually implement it. And so again, look at the look up how a knight moves if you'd like. Otherwise, you can think of, imagine I had a knight right here on e5 where my cursor is. The attack squares would be this one, 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 this one. Potentially 8 squares. And it won't hit, you can imagine if the knight's on the edge of the board like this, there's nowhere to jump out here, so it can have less than 8. We'll deal with that. Don't worry about it. We're going to keep this simple. So to start, I'm going to construct this list, and I'll call it squares. Why not? Equals new list of board position. And so we've initialized it. Now we can use squares, right? We got to do that. And then you can imagine eventually we'll return squares. So let's just load this up. Let's just assume that it has 8 spots. And if we jump out of bounds on the board, the challenge isn't going to, it's not going to cause any problems with the challenge. But I will add a little statement at the end that's optional where we can filter out those illegal values. That'd be a nice touch to add. But in general, you can imagine, since the board positions are now numbers, hopefully now you'll appreciate why we converted that that file value to an integer. I can start doing things like squares, add, and I'm just going to start in a clockwise manner. So if we were at e5, I'm just going to start here and go around the circle of knight moves and just list them all, not make any assumptions about like we started here and jumped off the board, and we'll clean that up. So I can say squares add, new board position, and then we'll sort of derive this based on the piece's current location, right? So we know that it has a rank, and so to go forward, I'm on e5. To go forward 2 spots, I'm going to go up 2 for the rank value. So I'm going to say rank plus 2, and for the file, I go over 1, because that's how knights move. 2 and then 1. Good. So we added that square, wherever that is. And now I'm just going to copy this 8 times. There are certainly better ways to do this. I'm just trying to keep this really simple. 5, 6, 7, 8. Okay. So now, to go to that next spot, right, your rank would be up 1, and your file would be over 2 to the right. And remember, we're just going around clockwise. That's how I'm going to do this. You could do it in any order you want. So next would be rank minus 1 and location over 2. Then you'd have rank minus 2 and over 1. That should be right. Then you'd have rank minus 2 and file over 1 to the left. We're making that clockwise shape, hopefully you can see. Then we'd have rank minus 1 and file minus 2. Then we'd have rank plus 1, file minus 2. And then finally rank plus 2 and file 1 to the left. And then you'd see we'd get back to the start. So this would cover all 8 squares. Again, not making any assumptions, but let's clean it up. We can do better than that. So let's bring our old friend Link in here to help. We can use where, remember, to filter out the bad squares. And so I'll put a lambda in here to take care of that. I'll call my variable, we know with lambdas we list the argument parameter first. I'll just call it pos, short for position. And then with this, basically I need to check that the rank and the row values are between the numbers 1 and 8, right? Nothing else. And to clean this up a little bit and maybe demonstrate something else about lambda functions, I'm going to make a little helper method here. I'm going to go, let's do it right here. I'll call it private static, right? This has nothing to do with objects. I'm just checking if values are legit, if they're between 1 and 8. And I'll call it, it's just going to be a Boolean, true or false. It's either valid or not. I'll call it valid rank row. And I'll take an integer, and it could be a rank or a row. I can use it for both because the chessboard is square. It's 8 by 8. The valid values are the same. So for this method, I can simply say return rank or row is greater than equal to 1 and rank or row is less than or equal to 8. Those are the only valid values, right? And then because I have this little helper method, and you could have defined this all in place in the lambda, right? That's how we've normally been doing it, but thought why not? We can show you a way where you could use an existing method name. So then I can simply say valid rank row position.rank and valid rank row position.file, right? We got to make sure both are valid. And then we know our return type is list here, and link gives us this handy toList to facilitate that. So here we just cleaned up in case, imagine the knight's on the edge and there's some invalid values there. You've got file 9 and 10, and we just drop all those here. Probably wouldn't cause problems if you left them, but why not? And then I'll go ahead and just add in using system link for 1, right? Because of the where method and toList. And then let's bring in system collections generic because we're using that list type. Good. So that was our knight. It has its unique implementation for get attack squares. Hopefully I didn't mess any of those up, but we'll find out when we test. Good. Now let's do the same kind of thing for the king. So don't want to make a new class here. Private class king, right? And that's going to inherit from chess piece as well, just like we did with the other one. Define our scope. Good. So what did we do for knight? Well, we made this constructor. I'll just copy it. Knight, of course, we're going to get yelled at. This should be king. It's going to take a position, and it's just going to forward it on to the base class and just say, hey, set your position like this. And the other thing we know we have to do is to override this method. Actually, I might take more. Let's just take the whole thing. Okay, but obviously a king doesn't move like that. But we got our override of this, and now let's make it unique for kings. And so the king, very briefly, can move one square in any direction from where it currently resides. So you imagine a ring around the king. So let's go ahead and update those values to be appropriate for a king. So we'll go board position, location, rank. Let's start with moving forward 1 on the same file. That should be 1. And then we'll sort of go clockwise from there. So it would be up 1, rank +1 is forward, file +1 is to the right. then we would have on the same rank, and move the file over 1 would be going right to the right. Then we'd have rank -1 would be backwards and file over 1 to the right. Then we'd have backwards 1 and the file should remain the same. Then we'd have go backwards 1 and make sure we go over to the left. Then we'd have rank the same and 1 to the left. And then we'd have rank forward and over 1 to the left. And that we should have made a ring around the king that way. And then the filter applies the same. If the king was in a corner on an edge and there were some dirty squares in there that are invalid, this will just filter those out. Good. So let's see, where does that leave us? You can expand your screen if that's helpful for viewing. So a couple things I glossed over here, right? One thing, and I'm sure I made errors because this was a lot of typing. We'll catch them when we run. But one thing I sort of glossed over, and maybe you caught it, was that, okay, great, contains. Yeah, contains has worked well for us in the past. We give it collections of built-in types, of native types like integers and strings. And what you don't see is behind the scenes is that there's some extra logic that sets that up so contains knows how to work with these known native types. But in this case, a location is a board position. That's just something we made up. The language doesn't know anything about this code that we've written. And so you can imagine this just wouldn't work out of the box, right? It wouldn't necessarily know how to compare these. It might just even blow up and say you can't do that. You've got to implement a method to do that. And so what I wanted to show you was what this list contains. That's where I'm at right now if you want to follow along. Notice this. Demonstrates the contains methods on a list, which we're using, that contains a simple business object that implements equals. So what they had to do with their class is they had to derive from this equatable, and then they override the equals operator to say what it means for this custom object for two of these things to be equal. And so that's what we have to do if we want contains to work. Otherwise, how would contains know how to work? Should it compare ranks, files, both? Sometimes you want all the properties, sometimes you might not. So feel free to go through that example. There's a cube one down here that might be helpful. Again, equatable of cube, and you can see it overrides the equals method to sort of achieve that. And so with our board position class, then we should be doing the same thing. It's still very simple, but we didn't quite cover that before. So let's do that. Notice they just put cube as the generic type here. So let's add that to ours so it knows how to check if a board position is contained. So where did I put our board position? See, normally these are all in separate files and you got a lot more real estate to work with. Here we go, board position. So we found out, okay, that's not quite good enough. We got to use this equatable. I'll put board position in here. And then because I do that now, I'll come down. And so now I can override the equals method just like they did. So I'll say public bool equals, and then board position is the argument, and a common way to name that is just call it other because it's being compared to this instance. You're taking two board positions and comparing them. And so you can probably imagine how you would define if two board positions were equal. It's pretty straightforward in this case, right? If their ranks are the same value and their files are the same value, they're the same thing. So I hope that's very clear. One thing that may not be necessary, but I'll do it. I'll just check to make sure this isn't null. I don't think this will be a problem. New argument exception, whatever thing you want in here. And then finally, the actual guts of it is pretty simple. We can return other. It's okay to access the rank property now because I checked that other wasn't null. If you had accessed it and it was null, then you're going to have problems. The null has no rank property. So if I say other rank is equal to this rank, and the this keyword just refers to the current board position in question. So one of them will be represented by this. And remember, we have this second board position that's supplied when the equal method is invoked, and that's not something we're calling, but it will come up when contains is called. And I know that's kind of hard, all this stuff happening that you don't see, but again, just try to roll with it for now. It'll become more clear. So we can't say just rank, right? And it's also other.file is equal to this file's integer value. Those integers should match up. So I think we're going to have a lot better luck now with contains. It can actually do something intelligent and that we have full control of. Hopefully you think this is really cool. It's powerful, right? It's like, holy smokes, now I can use all these methods with my own custom classes. I'm not limited to just integers and strings and the few built-in types. I can do this with any type I want. You know, I just have to do a little bit. I have to tell it how to analyze, right? And that's fair. How else could it work? So I think we've got most of our issues covered, but let's just run and they'll tell us what blew up. We don't have the benefit of an IDE here that will highlight a lot of errors that you make while typing. So yeah, a lot of dumb stuff coming. Maybe you've been screaming at me the whole time, but good. We want to practice this. It says it's on line 9. What do we do? Error, closing parenthesis. What did we miss? They do have a handy thing. Yeah, so you can see it. My board position is matched with the last parenthesis, but we didn't match this guy. So let's be sure to add another one in there. And one thing they do, I've noticed sometimes too, is you'll type it and it won't put the extra one at the end. It's like it's trying to help you, but it doesn't. I don't know if that's what happened here, but. Argument 1 cannot convert from object to string. Sure. So our getRank number method, remember we took a string representing the rank, and it's saying, hey, knight position 1 is an object. Fine. I'll do this old style cast to a string so it can treat it as the string that it is. Again, really ugly. No one would do this. Make an object array represent it. Even if you didn't want to make a class, the other thing I was going to show you is you got these tuples, right? You don't want to commit to making a whole class. So you can make these, it's like a pair if you're in C++ land, if you're coming from there. You can make these tuples, and look, they come in multiple sizes. You can pack all sorts of data in there. And if you go look at the examples, you're not stuck with just calling everything an object. You get to pick. You say, no, my first one's a string, and the second one's an integer that could be null, you know, but you can make these whatever types you want. And then you can treat them like those types, and you don't have to do all this BS casting. All right, rant over. Don't do object arrays like this. So let's see, hopefully I fixed that. Let's see what's next on the error list. Line, argument 1 cannot convert from object to int. So we got the same thing going on with these positions too. So let's make them integers so everything's happy. Okay, we're down to line 121. It was good practice in fixing errors. Go down to 121. And what did we do? Okay, ooh, yeah, that's not good. Another case A, I definitely didn't mean to do that. Totally missed one. So it said multiple cases with the label value A. That was nice of them. Because you can see A was up here. And I don't want A there. It should be A through H. Sorry again if you were yelling at me while I did that. Nice, there we go. Look at that green, beautiful. And so we don't claim victory though until we attempt. And nice, we hit it. So yeah, hopefully you appreciated some of this extra work to convert to numbers. Then I can just, when we're looking at squares, I can just, you know, say go over 2 or up 1. And you can imagine adding 1 to f, and you know, you can do it with characters and stuff. It's just a little uglier in my opinion. So I'm going to go through this, and I didn't use any print statements here, but hopefully if you were stuck, you were using those. And don't feel bad if you did. You didn't go to the trouble of making all these classes. When I submit mine, it's, you know, people are probably, if they see it, they're going to be like, whoa, dude, easy. You didn't need to do all that. It was much easier to just do this. But again, I'm hoping to try to help you out, introduce you to inheritance, you know, ideas like that. And because it's common, you're gonna want to make your own classes, your own types, and it shouldn't be scary. It should be something that you're comfortable doing. So let's just look at it. Let it go if it's a little intimidating. We got some enum action there. We got a pretty cool way to make this contains work with custom objects, which is awesome. Again, I won't go to the trouble. I know I've told you in the past, and I still believe this, that I like to have my public stuff at the top and the private at the bottom, because if someone's coming to work with a class I made and it's, you know, has some size to it, I don't want them to have to scroll down and look at all this stuff. If there's a few, and there should be a limited number of public items if your class is simple to work with, and they can just get that information right at the top. I'm not going to go to the trouble of this because I wouldn't even, in a real scenario, I wouldn't even put these all crammed into this same file. You know what I mean? Chess piece would be its own file, and knight would be its own file, and king would. But you know, you don't have to call me out like, hey, you said put public stuff at the top, you know, to help your users and stuff like that. Yeah, you should do that when it comes up. So please don't kick me for that. I know what I'm doing here. It just that wouldn't happen in a real scenario. So, and if you really want, you know, cut and paste these around, put the private stuff at the bottom. I don't think people are too worried about that. So yeah, that was the general approach here. And you can see from this standpoint, it's pretty easy once you have these methods, right? And once you have pieces that you can make with positions, and they sort of have everything you need already built into them, then it's just a matter of like, make your pieces, invoke their behaviors, and make a judgment call based on the results you get. And you get this nice thing that's only a few lines long. Someone who doesn't even know how to code could look at this and probably understand what I'm doing here, you know, and that's cool. You don't necessarily, I'm not saying you should write for people that don't understand code, but when things flow in a sort of a natural English way, or whatever language you're using, that's really helpful for people that come into the project new, or when you have to go back on it after some time away. So yeah, you might have questions about this, so don't be shy. I'm here to help. Yeah, I'm gonna go ahead and minimize this. I don't think I left any fluff comments or anything in there. So I'll just go ahead and submit like I have, even though the order, you know, the mixture of public private bugs me too. But we'll just let it be. I hope you found this really useful. Get your points. I went over 900. Yeah, party. Maybe a party when I go over 1,000. But again, you know what to do. Look through these. See that you can do these much simpler, but I was trying to do something that could help people. Yeah, see what else you can learn. Cool. Oh yeah, we had someone else. Nice. All right. Yeah, see you in another video. Thanks for watching.